Today we're going to jump into 3 different types of graphing quadratic equations. This first one is standard form. Please write that down on your notes. This is standard form. And there's a couple things that we can tell. There's a couple things that make it easy for us in graphing in standard form. Please draw an arrow to the very last number. This always tells us what the y-intercept is. So I know the y-intercept for this problem. I can right away identify it as 0, 12. Another thing that helps us here is please draw an arrow to the negative sign. Not the 2, but the negative sign. And I'm just going to draw a picture. Because it's a negative quadratic equation, I know this parabola shape is going to open downward. Okay, so let's go ahead and let's identify the line of symmetry. So x equals negative b over 2a. In this problem, a is negative 2, b is negative 4, and c is 12. And so I'm going to use algebra to plug this in. X equals negative 4 over 2 times negative 2. Two negatives create a positive 4. Two negatives create a positive 4 over negative 4. So when I reduce, I end up with negative 1. This tells me what my axis of symmetry is. So I'm going to go on the x-axis to negative 1, and I'm going to make a dotted line going up and down. Today you will practice these individually. Tomorrow you will have a quiz on this individually. Now we're going to find a vertex. Now a vertex has 2 points. It has it has 2 coordinates, an x-coordinate and a y-coordinate. The x-coordinate is always the same as the line of symmetry. So on this line of symmetry, we're going to find either the highest or the lowest point, the maximum or minimum, which will be the vertex. Now, how do we find that? We're going to now grab our calculators, and I'm going to plug this in, but I'm not going to type in an x. I'm going to substitute a negative 1 for an x. A common mistake students make is that whenever they plug in a value, they don't put parentheses around it. That would make this final outcome, or the y-coordinate, wrong if we don't use parentheses. So let's start with negative 2. Parentheses, now I'm going to substitute in a negative 1 squared, subtract 4, again for the x, I'm going to substitute in a negative 1 plus 12. When I press enter, that will give me the outcome, or the y value of the vertex, which is 14. So I know that this is a little bit past it. I'm going to have to kind of predict here. So this is 10, 11, 12, 13, and 14. Okay, now off to the side here, I'm going to write small, and I'm going to write x and y. And you've had 10 days off, so it's very possible that you forgot this. But 0, 0, what's the next one? 1, 1, 2, 4, and 3, 9. Please do me a favor and draw an arrow from the negative 2 to the y value. Whenever the leading coefficient, the number in front of the x squared, is anything other than a positive 1, we have to multiply the y's times that number. So 0 times negative 2, that's still 0. 1 times negative 2 is negative 2. 4 times negative 2 is negative 8. And 9 times negative 2 is negative 18. This will provide me the opportunity to accurately graph this quadratic equation. So from this point, I'm going to go, this is like my 0, 0. This is the vertex if you're forgetting. So I'm going to go 1 to the right and 2 down. So 1 to the right and 2 down. Then I'm going to go back to the vertex and go 2 to the right and 8 down. Okay, 2 to the right, and I was at 14. If I go 8 down, I'm going to be at 6. Then I'm going to go 3 to the right and 18 down. So 3 to the right, and here's 14, 15, 16, 17, and 18. And then I will do the numbers that are on the other side. So this is 2 away and 2 away, 3 away, 1, 2, 3. I'm going to go ahead and do the domain and the range, and then we're going to come back and we are going to identify the x-intercepts. So the domain for this problem, please go out to the side here and write the domain for parabolas, if they have no restrictions, is always going to be negative infinity to positive. It always continues to open up or down as it moves to the left and to the right. There's no restrictions how far it goes to the left and right, again, as it opens down, or in other cases, opens up. Now the range is a little different. We always have to identify the smaller of the two numbers first. So if there's a negative number, it's the smaller of the two negative numbers. These arrows are going to tell us that there's no limit how low this goes, and the range is describing the y values, but it goes up as how high, and that value is going to be right here. So it goes up as high as 14, and that's part of the graph. The last thing we're going to do is we're going to identify the x-intercepts, and so as a reminder, yes, we could use completing the square, which you learned freshman year. We can use factoring, and I'm going to put a question mark because factoring doesn't always work. Not every trinomial is factorable. We can always use the quadratic formula. We can always use the quadratic formula. And that's what I'm going to practice with you today. I'm going to use the quadratic formula over here, my A, my B, and my C. And I'm going to identify, using that, what are the solutions. The solutions, when I solve, will be the accurate x-intercept. So let's write this down. X equals negative b plus or minus b squared minus 4ac all over 2a. All right, so I'm going to replace the b with a negative 4. Anytime I'm plugging something in, I'm putting it into parentheses. And I'm going to show you, I'm going to give you a chance to catch up here, and then I'm going to show you how I use my calculator to do the hard work. So all I've done is I've taken the quadratic formula and I've just replaced the A, the B, and the C with specifically what A, B, and C are for this equation. Okay, let's see how we can use the calculator as a tool. Two negatives make a positive, so I know this is positive 4. I'm going to leave this blank right now, and 2 times negative 2 is negative 4. I'm going to grab a graphing calculator. I am not going to put down the square root. I am not going to put down the square root. I'm only going to take the numbers, think of this as an expression underneath, and I'm going to use the calculator in order to figure out what would that value equate to when I evaluate what's underneath. It's called the discriminant. So here we go. Parentheses. If you don't use that parentheses, this is going to be wrong. Negative 4 squared, subtract 4 times negative 2 times 12. Okay, I'm going to press enter, and I end up with 112. None of this is wrong again. None of this is wrong. Please take out these papers. If you have this paper, please take this out. Sorry, I threw it in the garbage can thinking I didn't need this today. And we're going to see is 112 on there. 112 is not on there. Grab a calculator and begin dividing as you go down by these perfect squares. We need to select the largest one that divides into 12 if one exists. So 112 would be right here. So I'm taking 112, divided by 100, 112, 81, 49, 64, 112, 49, 36, we know 25 doesn't work, 16, 16 works. 16 is the largest perfect square that divides into it. So I'm now going to rewrite this as x equals 4 plus or minus the square root of 16 times the square root of 7. The square root of 16 is 4. At this level of math, we need you to reduce as far as possible. So I'm going to underline with a different color these 4 numbers. I'd like you to do the same. You can use your pencil or pen. If we are able to reduce this, this number will be able to be reduced with each one of these. So each one of these is divisible by 4. Each one of these is divisible by 4. So I'm going to divide, I'm going to divide each one of these by, and we could go like this. We could separate it and go 4 over negative 4, 4 over negative 4, and square root of 7. That's one way we could do this. So when I write down the x-intercepts, which is right here, I'm going to make a spot here that shows up. These are the exact answers. 4 divided by negative 4 is negative 1. 4 divided by negative 4 is negative 1 again, and then we have the square root of 7. For a lot of students, they go through the process of doing the math where they're like, oh, that doesn't really make sense to me. So let's see what that would look like on an actual graph. The very first time I'm going to add. So I have negative 1 plus negative 1 times the square root of 7. Okay, so is negative 3.6, 1, 2, 3, is negative 3.6 approximately one of my x-intercepts? It is. Negative 1 subtract negative 1 square root of 7. Is 1.6 approximately the same area as where the other x-intercept is? It is. I do not want rounded answers. We need to show exact answers. This is referred to as vertex form. And why I like this form is I like to do the least amount of work. We are easily able to identify the coordinates of the vertex in this form. We also, based on the number that's out front, we can tell whether it opens up or down, and we can tell, just like we did in our previous example, if it's going to be generally wider or skinnier than the parent function of a quadratic formula, or quadratic function, excuse me. So this tells me that it's going to open up because it's positive, and it's actually going to be skinnier than the parent function. The vertex, now listen to this, please put, and you may have learned this freshman year, put a frowny face underneath the X, and the number in back, put a smiley face. Unfortunately, what is in parentheses always lies to you, every single time. So when we think of a vertex having an X and a Y coordinate, it's always going to lie to you for the X coordinate. So you're not going to write down negative 5, it's positive 5. The Y coordinate tells the truth, negative 4. Now we're going to come off to the side and we're going to graph that. So I'm going to go over 5 and I'm going to go down 4. 1, 2, 3, and 4. We are done. Okay, then I'm going to make a dotted line here. Miguel, can you check real quick with Jeremiah? And then you can go back to doing whatever you need to do to see if they need any help. Okay, this is my line of symmetry, known as the axis of symmetry. It cuts through the x-axis at a value of 5. These numbers will always be the same. All right, so we're going to come off to the side and write down our pattern for quadratic equations 0, 0, 1, 1, 2, 4, 3, 9. You may be asking yourself, how does she come up with those numbers? As a review, I'm plugging in an input of 0, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. That is the parent function for quadratic equations. But what are a lot of students going to forget? They're going to forget that whatever number is in front, if it's anything other than a positive 1, we have to multiply it times the y values. 0 times 2 is still 0. 1 times 2 is 2. 4 times 2 is 8. And 9 times 2 is 18. Another great question students often have is, how do I know if I go up or if I go down? These are directions. This is always our vertex. If it's positive, we first move to the right, and if it's positive, we move up. So I'm going right 1, up 2. Right 1, up 2. And then I always go back to the vertex to follow the next directions. Right 2, and I go up 8. So from the vertex, right 2, and up 8. And then right 3, up 18. And we can see that's going to be past this. So right 3 and up 18. Well, there's 14, 15, 16, 17, 18, somewhere right there. And then I'm going to do the reciprocal, or not the reciprocal, excuse me, I'm going to do the points on that are reflected across the line of symmetry. I'll give you a chance to get caught up. Yes, go ahead. How did I get these blue numbers? I take whatever number is out front. So here it's a positive 2, and our previous one, it was a negative 2. So it's your leading coefficient, and you always multiply that by the y's. So 0 times 2, 1 times 2, 4 times 2, 9 times 2. Every single time. The only time you don't have to do that is if this number is a positive 1. Otherwise, we always do it. Okay, positive 1 is the only time we don't have to do it. Okay, here we go. So let's talk about domain. What is domain for all parabolas with no restrictions? It's going to be negative infinity to positive. As a reminder, we have to put the smaller of the two numbers first. So when I'm talking about the range, it goes as low as -4, and it's included, and there's no limit how high it goes. Okay, end behavior for this. So I'm going to write this out. I'll let you do the same. Now the really nice part is that end behavior of parabolas are always the same. The ends are either both going up or they're both going down. And in this case, when we go to the far left or the far right, we can see that the ends of this parabola are going upwards. And we are going to illustrate that then with writing down a positive infinity. There's no limit how high they go. So here we go. For this one, please write down two forms here. Intercept form, and other people refer to this as factored form. They're the same meaning, the exact same meaning. Why do we like this form? Because we can very, very easily determine the x-intercepts. With pretty much no work, we can determine the x-intercepts. We're going to take each one of these factors and I'm going to set it equal to 0 and I'm going to solve. Some of you can do this in your head. So subtract 4 to both sides, x equals -4, add 2 to each side, x equals +2. So the x-intercepts would be -4, 0 and +2, 0. -4, 0, +2, 0. Please draw an arrow in front of the negative sign. Whatever's in front is going to tell us, does that general shape of that parabola, again, is it wider or is it skinnier than the parent function? And in this case, because it's negative, we know it's going to open downwards. Now, there's mathematically a way to do this, but this is what I like to do. I literally like to take my fingers and I'm going to go one by one to find the middle. So I'm going to go over 1, over 1, over 1, over 1. And what's the middle? The middle value is -1. So go to -1 on your paper. I'll give you a chance to get caught up. And I want you to make that dotted line. And you're wondering algebraically, like, Miss Bradley, like, my fingers are big and my nails, I can't figure that out. Well, the other way to do it is once you determine your x-intercepts, that's the first thing you're going to do. You're going to add those values together. So I added them together, and then you divide by 2. That's going to tell you that middle number. In this case, it's -1. So whether you want to do like me and go like this, or maybe we'll end up some point on not landing on an integer, you add your x-intercepts and divide by 2 to find that middle number. Okay, let's go over to line of symmetry. Go over to line of symmetry, and we're going to write down the equation. So x equals -1. Your vertex x value and your line of symmetry are always the same. So how do I figure out what the y coordinate of the vertex is? We'll grab your calculator and we're going to plug this in. So we have -1. That negative sign is like a hidden -1. And I'm not going to type in x. My x is -1. So it's -1 plus 4 and -1 minus 2. Whatever I get for an answer will be the y coordinate of the vertex. So in this case, it is 9. So I'm going to come up here to 9, all the way up to 9, and make a dot. Zero, 0, 1, 1, 2, 4, 3, 9. Okay, so who can tell me right now? Take a risk. I do not care if it's a wrong answer. What do I have to multiply these by? A negative sign. Yep, draw a little arrow here. And if you're like, well, what number is it? It's a -1. Anything other than a positive 1, if this is a positive 1, we don't have to worry. So 0 times -1, that's still 0, times -1, times -1, and times -1. And that provides me directions in order to create a more accurate shape of this parabola. So from the vertex, I'm going to go 1 to the right and 1 down. 1 right and 1 down. Then I go back to the vertex and go 2 to the right and 4 down. 2 to the right and 4 down. 1, 2, 3, 4. Then 3 to the right and 9 down. Since we know parabolas are symmetrical. And we're lucky, we can already see what the y-intercept is. What is it? We went right through the y-axis at a point of 0, 8. But what if we did not go through? So every single function always has one y-intercept, just as a reminder. But what if we couldn't see it on the picture? If you can't see it, you can come up to the original formula and you plug in a 0 wherever you see an x. So if you're watching here, I would go 0 plus 4 times 0 minus 2. And we get the same answer of 8. Or in this case, we can see it right on the graph.